So chapter number 2 is about kinematics. Kinematics comes under motion. There are two types of motions, kinematics and dynamics. Chapter number 2 deals with kinematics and chapter number 3 deals with kinematics. But before getting into that, let's discuss how many states of the body do we have. There are two states of the body. And that's purely dependent on some observer. We must keep this in our mind that these states totally depend on the state of the observer. And that is rest and motion. If a body does not change its position with respect to observer, it is said to be rest. And if it needs another color, still not visible. This, what kind of a color is this? White. Let's say if a body changes its position with respect to some observer, it's said to be in a state of motion. So when it comes to motion, motion is further divided in two types. Two states, we could say. That is kinematics and dynamics. One thing we should keep in mind that the motion cannot occur without the application of force. Okay? If there is some kind of motion, it must have been there's some kind of force that was applied to a body which caused that motion or stopped it whatsoever. If we discuss the force, the application of force for the motion, it is said to be kinematics. And if it does not discuss the application of force, so if application of force is into consideration, it is said to be kinematics. Force is always there. If we discuss force and its application, it is said to be if we do not discuss the application of force in terms of formula or in terms of theory, it is said to be kinematics. And if we discuss the application of force and application of force in terms of theory and in terms of equations, that would come under dynamics. But always keep in mind that the motion would always require some kind of force. But if we discuss it, it's dynamics. If we do not discuss the application of force, it would be kinematics. Clear up till now?
Yes.
The motion that we're going to discuss in kinematics would be the speed, the acceleration, the displacement of the body, the distance covered by the body. All these terms would come under kinematics. Let's discuss and first review what they have discussed in the start of the chapter, and then we would move on the types of motion and discuss EMA and kinematics. This table is good for in order to get to the kinematics. This instrument is further on. Okay. The types of motion that we're going to discuss in kinematics is translatory motion, rotatory motion, and vibratory motion. To and fro motion of an object is known as vibratory motion. The circular motion around a fixed position is known as rotatory motion, and the change in position of a body as a whole in a linear motion is known as translatory motion. Okay? They have given the definitions alongside with it. The change in the position of a body as a whole, the line or path of the motion could be straight, curved, or random. Complete change in motion of a body is known as translatory motion. For example, the motion of a ball, car, flying bird, or aeroplane. It could be linear, it could be circular, it could be curved. Random motion, sorry, curved, circular नहीं. तो circular के लिए हम लोग इसको discuss करेंगे. Rotation of a body around a fixed rotation is known, axis is known as rotatory motion. The particle of an object in rotation moves in a circle. For example, motion of a helicopter rotor, blades, or a fan. To and fro motion of an object is known as vibratory motion, and the example would be the motion of a swing, string of a guitar, or a simple pendulum. We could add these. Translating motion is further divided into three types: rectilinear motion, curvilinear motion, and random motion. As उन्होंने यहाँ पे हमें discuss भी कर दिया है कि the motion could be in a straight line, in a curved, or in a random motion. So अगर random motion होगा तो उसको translatory के अंदर random motion में आएगा. If it's a curved, it would be curvilinear motion, and if it's in a straight line, it would be a rectilinear motion, as written below. Straight line motion is a rectilinear motion. Circular or curved path motion is curvilinear motion, and irregular motion. Up there comes the difference between a rotatory motion and a circular motion. Rotatory motion is always at a fixed rotation, around a fixed axis वो move कर रहा होता है हमारे पास, ठीक है? Whereas curvilinear motion is around a, for example, if I tie one end of the string at one end and I rotate this like this, so it is moving around this fixed position. This would be known as a rotatory motion. But if an object is moving in a circular path without any fixed position, it would be known as a circular motion. They have discussed the difference between these two maybe and further in detail, but do you get the types of motion? How many types of motions do we have? Translatory, translatory,
rotatory and vibratory.
and translatory is further divided into how many types?
Linear motion, curved motion, and irregular motion.
Random motion. Okay. The examples are given below. If they ask in a short question, this is a vibratory motion, the motion of a swing. This is a rotatory motion around a fixed position, and this is a translatory motion. And this wall motion, if it's go back and forth, this would be a vibratory motion, and an example of a vibrating motion. Okay.
Okay.
Rest and motion भी discuss हो गया, types of motions भी discuss हो गए. Now we have we could see here in all these types of motion we have not discussed the motion and we have not discussed the application of force anywhere. Force is there because without force this could not be possible, but we do not discuss the application of force in terms of theory or anywhere else. Distance, displacement, speed, velocity, and acceleration. These would be the 5 topics that we are going to discuss today, and this would be the end of today's lecture. What are those? In kinematics, we discuss distance, displacement, speed, velocity, and acceleration. Okay. All these 5 categories come in kinematics. I'll explain it to you here and then we'll go through it in the book. Distance is defined as the actual path covered by the body. Displacement is defined as the shortest distance between 2 points. Okay. Distance is defined as, in terms of physical quantity, distance is a scalar quantity. It's a scalar quantity, and displacement is a vector quantity. In order to find the distance, we will add the distance between 2 points. And in order to find the displacement, we would minus or subtract the distance between 2 points, because displacement is a vector quantity and it would be the shortest distance between 2 points. They might have drawn the diagram as well. See, this whole motion of the body would be known as a distance covered by the body, and the shortest distance between 2 points would be known as a displacement.
Displacement.
See, this was the actual path covered by the body. This was distance, the circled with red, and this orange point, the distance, shortest distance between 2 points is known as displacement. In order to find the displacement, we subtract the distance between the 2 points, and distance is the actual path covered by them. They might have given or discussed that before as well. If we're going in a circular path like this, if we have started from this point and we have come back to this point, the displacement would be 0, but the distance covered would be whatever the distance it has traveled across this path. Okay. The length of the path traveled between two positions is called distance, and the shortest distance between initial and final position is known as displacement. Definition is written right here. Then come speed and velocity. Speed is defined as the rate of change of distance, that is distance divided by time is speed, and velocity is defined as the rate of change of displacement. So velocity would be equals to displacement over time. I mean, out of the speed and velocity, which would be a scalar quantity and which would be a vector quantity?
Displacement is a vector quantity and distance is a
So the velocity,
scalar.
So the velocity would be scalar or vector?
Vector.
Yes, so the velocity would be a vector one and the speed would be a scalar. But since both have the same kind of formula, they both would be. अब distance and displacement का unit क्या होगा?
Distance is in meter and displacement is in
Would
meter,
also be in
but with
meters.
respect
And time,
to
what is the unit for time?
seconds.
Yes, so the unit would be both for
Meters
speed and
per
velocity would be meters per second. Here you could see the definition. Measure of distance covered with passage of time is called speed and is denoted by v. And velocity is measure of displacement with respect to time is called displacement with respect to time is called velocity. Both have the same formula and the same units. We would go into the details. The types of speed we're going to is average speed, instantaneous speed, and uniform and variable speed. I'll get to these topics once you review the topic up till here. You have the book on your end as well, no? Average speed is defined as the total distance covered by a body in total interval of time. The instantaneous speed is defined as the distance covered by a body at a particular instant of time, that is known as instantaneous speed. And the last thing, what was the last point? Uniform speed and variable speed. Uniform speed is defined as if the object covers equal distance in equal interval of time. It is known as uniform speed. And if the body does not cover equal distance and equal interval of time, it is known as variable speed. This means if we are going in a car and we are moving with a speed of 80 meters per second, whatever the speedometer does, excuse the unit use. This, if the speed of the car is not changing over a period of time, it would be known as constant speed. If the speed of the car is changing regularly in regular interval of time, that the speedometer is going to the next point in a regular interval of time, it would be known as uniform speed. And if the speed is changing irregularly over a period of time, it would be known as variable speed. Clear?
Are constant speed and uniform speed the same thing?
No, uniform speed is the one if the speed is changing equally with equal interval of time. And constant is the one in which the speed is not changing over an interval of time. Constant means no change. It remains same
Okay.
over a period of time. Like, let's go through the theory that they have written. If we calculate the speed or entire, if we consider a large distance between two places and a total time that elapses, the increase or decrease in a speed would be average. Average speed is the total distance covered in total time, as I told you. They do not have the formulas here. I don't know why. It is present there, but I think so during the copy it didn't came out. Instantaneous speed is defined as the speed at any instant of time. लिखा हुआ है यहाँ पे. The speed at any specific instant of time is called instantaneous speed, and uniform speed is defined as if an object covers equal distance in equal interval of time, it is said to be a uniform speed, and the variable speed is defined as they have not given the definition of variable speed, but if the distance of the body does not change equally with equal interval of time, it is said to be a variable speed. You do not need to memorize the speeds for these objects, but you should read them so that you might have some examples to work to write on. Let me take you to the other book. स्केलर एंड वेक्टर्स हम दोनों प्रीवियस लेसन के अंदर पढ़ लिया हुआ था. Here we could see the example that I was telling you, na, that if this is the total distance covered, like this whole path, this from point A to B, this is distance, and the shortest distance between these 2 points is A to B. This is displacement. Displacement is a vector quantity, so it has a direction and magnitude, and this distance is a scalar quantity, only has magnitude in it. And if we go through the types of motions from this book as well, translatory motion, linear motion, random motion, and circular motion, same thing. Rotatory motion around a fixed position, and vibratory motion, which is to and fro motion of an object. The body moves along a straight line without any rotation. The line may be straight or curved. Same definition with the examples alongside. Linear and circular motion of translatory motion, जिसको हमने पढ़ा था वहां पे. Random motion, the third type of the translatory motion. Rotatory motion is around a fixed point. Examples they have shown that this one, इसको क्या कहते हैं, मेरे माइंड से निकल गया. What do we call it? Topper? Okay. And the football moving like this, and the cycle, and this, because all these circular motions are around a fixed positions, that's why they are known as rotatory motion, the spinning of a body about its axis. Only we have more examples and diagram alongside it. There is no further difference between these two and the vibratory motion. This kind of motion on a seesaw is a vibratory motion. Scalar vector ने यहाँ पे किए हुए हम लोगों ने last time discuss कर लिए हैं. Resultant forces उन्होंने यहाँ पे discuss किए हुए. If the forces are acting in the same direction, it would add. If the forces are acting in the opposite direction, it would cancel out. If the magnitude of the forces are same, the arrows, the length of the arrow explains the magnitude of the vector. So if the length of both F1 and F2 is same, this means the magnitude is same. Okay. A vector is represented by bold letters or with arrowhead on it. That was not given in the other book. ये एक important है. The position describes the location or place of a point with respect to some reference point which is called origin. Distance and displacement की definition हमने discuss कर ली नहीं है. Speed and velocity, this is an important. Falcon can fly at a speed of 200 kilometers per hour and cheetah can run at a speed of 70 kilometers per hour. They have the formula. Formula उधर नहीं लिखा हुआ था, यहाँ पे है भैया. Speed distance covered over time and distance would be equal to speed into time. Uniform speed की definitions यहाँ पे हैं. If a body covers equal distance in equal interval of time, it is known as. ये क्या हो गया? How can I go back? This मुझे सारा circling करना था. नहीं हो रहा. Anyhow, it's not going back. Uniform velocity, exact same thing, but in instead of speed and distance, we would, as I told you before, that we would replace the word of distance and speed with displacement and velocity in the same definition. Everything would be same. Rest of the thing would be same. Have you reviewed the examples? Two? The solved examples in between, if there were any. Like example 2.1.
No, I didn't.
And 2.2. Because उसके अंदर values इन्होंने put नहीं की हुई, so we cannot do that. One of my colleagues sent me the book as well. Let me see if they have all the information. The next topic that they have discussed here is what would be the values of velocity when the object is moving in a circular motion or a curved path. So we need to keep in mind whenever an object is moving in a circular path, the velocity, the linear velocity would always be tangent to that circle. That is, if at any point the force that is keeping the object moving in a circle becomes zero, they would go in this direction. The satellite would go like this. So the linear velocity in a circular path is always tangent to that curved path. So if the curved path is like this and the object is at this point, so the tangential velocity would be like this. If the object is at this point, the tangential velocity would be like this. This is basically the path that the object would follow if the force that is keeping the object moving in a circular path becomes zero at any point. Whereas the force and the acceleration, they both act towards the center. The force that is keeping the object moving in a circle, it acts towards the center of that curved path. And the acceleration is also acting in that direction. Okay. Acceleration is basically, suppose we are moving in a circular path. Okay. And the examiner asks, in which direction the velocity is acting. Okay, once removed, it cannot go back. Okay. Normally, the linear velocities पढ़ी है ना? The object is moving in a straight line, its velocity would be somehow whatsoever. But what if the object is moving in a circular path? What would be the direction of the velocity in a circular path? So we would say that it would always be tangent to the curved path. Okay? Tangent is defined as a line which touches the circular path at one point only. It's a tangent. Tangent is a line which touches the circular path at one point only. So whenever an object is moving in a circular path, like in figure 2.9, its velocity would always be tangent to the circle. That's how we know that in a circular path, the velocity remains constant. The magnitude of velocity remains constant. But let me first explain you what acceleration is, then we get back to this one. Acceleration is defined as
speeding up.
Change of velocity over time. Okay? If acceleration would exist only either if speed is changing or the direction is changing. Acceleration is defined as the rate of change of velocity. Velocity is a vector quantity, so it will have its magnitude and direction. As long as any one of the quantity is changing, whether the magnitude or the direction is changing, acceleration would exist. If none of it is changing, acceleration would be zero. So if someone says that the object is moving with a constant speed, what would be the value of acceleration? So what would be our answer to that?
0.
Because for acceleration to exist, the velocity must change, either in term of its magnitude or in direction. Now I'll get back to this one. So when an object is moving in a circle, the velocity remains constant. But why the acceleration exists? Can you tell? Why there is acceleration if the speed is not changing? Look at the diagram, you'll get the hint from there. What is it? What are the two conditions for acceleration to exist? What did we discuss?
The velocity and the direction.
The direction. See? So if I'm saying that moving in a circular path, the speed is constant, but yet again the acceleration is existing. What could be the possible thing that is changing in a circular path?
Direction.
The direction. Because we could see at every point the direction is changing from these arrows. And these arrows are tangent to the circle, they would be drawn like this. And these arrows also tells us that if at any point the force becomes zero, they would follow this path. Follow this trajectory. Okay. So acceleration is defined as the rate of change of velocity. That is, if the velocity is changing with respect to time, then there would be another quantity that we'll discuss, and that quantity would be known as acceleration. For acceleration to exist, either the speed changes or its direction changes. If both are changing, acceleration would exist. If none of it is changing, acceleration would be zero. So when an object is moving with, yes.
Can acceleration be for speed too?
Sorry?
Can acceleration be for speed too?
No, basically we're using the term speed is because we're talking about the magnitude only. Normally, we do not use it in terms of speed. We do not discuss in terms of definitions of speed. I'm using the word speed because I'm talking about the magnitude only. Well, the only difference between speed and velocity is what? Of the direction. Velocity has direction, speed does not has direction. Rest of thing is same. So for acceleration to exist, either the speed changes or the direction changes, or I can use the word velocity because it has both. For acceleration to exist, the velocity must change. If the velocity is not changing, the acceleration would be zero. That is the topic of our next, that is our next topic in which we'll discuss that in detail, what would happen. Like see, in all this, in this motion, the velocity is changing alongside with the direction of it. So acceleration would be equal. Now this is the important section. Acceleration is a vector quantity with same direction as change in velocity. So units क्या बनेंगे acceleration की?
Acceleration.
What is the unit for velocity? What was the unit for velocity?
Meter per second.
And
meter per second.
And what is the unit for time? So meter per second would be equals to meter per second square. Did you get this? Velocity is meter
Not
per second,
really.
and velocity has a unit of meter per second. Okay, and time has a unit of second. This second would come in the denominator, and multiplied with second, it would become second square. So velocity is acceleration meter per second square. You know the rules for the mathematics, na? If I write this 2 by 3 by 3, what would be the answer of it? 2 by 6. Similarly, if it's meter per second, this would become meter per second square. Also keep this in mind. If you see this delta sign, This is known as delta. It means
Yeah.
change of the quantities. Okay, something final minus initial whenever you see this. So we have the unit of acceleration here. It's meters per second square. Acceleration is measure of how rapidly the speed is changing. Then we discuss about the positive acceleration and the negative acceleration. As we are discussing that acceleration is directly linked with velocity. So if its velocity is increasing, this means acceleration is increasing and it's positive. And if velocity is decreasing, so is the acceleration, and it would be known as decreasing acceleration or deceleration. A positive acceleration means an increase in velocity with time, whereas the negative acceleration means or deceleration means a decrease in velocity. अच्छा, इसके अंदर एक और पॉइंट हम लोग ऐड कर सकते हैं. We might read that topic in the later stage as well. When an object is moving in the upward direction, its velocity decreases
Okay.
until it becomes zero when it reaches the maximum height. At maximum height, it becomes zero momentarily, and then it start coming back. So when it's coming back, the velocity increases. So we can say that acceleration is negative while going up, and velocity is acceleration is positive while going down. Okay? As velocity is decreasing while going up, so the acceleration would be negative, and velocity is increasing while coming down, so it would be positive. Normally, when there is no air resistance present, we say that the object is falling freely and acceleration has a constant value, which is known as acceleration due to gravity, and its value is 9.8. Free fall object has constant acceleration known as
Free fall. No, good
accel
acceleration due to gravity.
yes, acceleration due to gravity. And we write it as, then acceleration is replaced by g. This g is known as acceleration due to gravity. Since acceleration has a unit of meter per second square, so g ka unit bhi kya hoga? Meter per second square, and it has a fixed value of 9.8 meter per second square inside the earth surface. हम earth surface से बाहर जाएंगे, उसकी values accordingly change होंगी. When do we replace a with g? We call that motion a free fall
When
motion if there is no resistance present. Okay. If resistance is zero, that is no air resistance is present, then the object will fall freely, free fall object, and has a constant acceleration known as acceleration due to gravity. The free fall motion is due to zero resistance. Do you know what resistance and friction is?
yeah.
It is the opposite force that acts in the in the direction of motion. A force that acts in the opposite direction of motion is known as friction or acceleration. Clear? This is the topic motion due to gravity that I was explaining to you. When the air resistance is absent, all the object falls with same speed known as acceleration due to gravity. Mass independent हो जाता है object free fall कर रहा होता है. The mass does not matter. Clear?
Yeah.
Now let's read this point. When an object is changing its velocity at the same rate each second, we call it a uniform acceleration. A body has uniform acceleration if it has equal change in velocity. वही जो मैंने आपको last lecture में बोला था ना, only the terms would change, बाकी definition as it is रहेगी. So uniform and non-uniform का भी क्या होगा? If the velocity of the body is not changing equally with equal interval of time, तो वो non-uniform हो जाएगा. If it's changing equally with equal interval of time, that is after each, मैंने एक fixed time रखा है, after each 10 seconds I would see the speed. If after each 10 seconds my speed is changing equally, then we would say the acceleration is uniform. If the speed is not changing uniformly with respect to time, we would say a non-uniform acceleration. ठीक है?
Okay.
Acha, we'll get back to this example. Non-uniform acceleration occurs when an object velocity changes, but this change is not steady over a period of time. आगे उसने ये लिखा हुआ था rate at which object velocity changes is not the same throughout its movement. Acceleration, which is a measure of the change of velocity. आगे उसने यूनिफॉर्म लिखा हुआ है यहाँ पे उसने बोला हुआ है कि in which case there would be an acceleration. We'll get back to it once we are done with the topic. यहाँ पे लिखा हुआ है acceleration due to gravity is directed downwards towards the center of the earth because gravity always acts in the downward direction. So acceleration due to gravity भी downward act करेगा and its value is 9.8 meter per second और 32.2 feet per second के यूनिट्स जब चेंज होते हैं तो उसकी वैल्यूज पे अकॉर्डिंगली चेंज होती है और मैं वही आपको जो पॉइंट बोला था ना all free falling objects have the same acceleration called acceleration due to gravity and it is independent of their masses. If I have thrown a stone and a feather together, both will fall with the same constant acceleration because it is independent of mass. The friction acts on the masses. So if the mass is ignored, this means everything would fall with the same speed. As they have given the example as well. However, when air is removed, the coin and the paper will experience the same acceleration due to gravity and both will fall at the same rate. इसके अंदर obviously जब air present होगा coin will fall faster but अगर हमने air remove कर दिया both will fall with the same speed. Are we clear up till now?
Yeah.
Okay, this page is good in order to understand the four graphs of distance time. Distance time के अंदर four shapes होती हैं हमारे पास. The first one is this one. This shows that the object is at rest. Body at rest. उसकी speed क्या होगी? 0. As there is no change in the distance traveled by the body, so the body is at rest. If we see this type of a shape, it means the object is moving with constant speed or uniform speed. दोनों के लिए हम इसको use कर सकते हैं. ठीक है? Either for constant speed, either for uniform speed, because we do not have any other shape to explain. These shapes will help you to write the theory that with what speed the object is moving. Okay? If we are seeing this type of gradient, it would means the speed is variable and it's increasing. And if we see this type of the shape, it means the speed is decreasing and variable. So, बल्कि नीचे theory में लिखा होगा इसमें, why should I write it? Increasing speed, the distance is changing non-linearly with time. The slope is increasing, therefore the object has increasing speed, and the distance is changing again non-linearly with time, and the slope is changing, therefore object is decreasing. So if we see a curve like this, that is going up like this, it means increasing speed. And if speed is increasing, it means acceleration is positive. And this means decreasing speed and acceleration is negative. अच्छा, अब these graphs were distance time graph, ठीक है? Velocity time graphs में इन दोनों graphs का meaning same ही रहता है. They have the exact same meaning in velocity time graph. ये तो दो shapes है ना, that only changes in speed time graph. यहाँ तक समझ में आ गया? Then I'll take you to the next type of graphs.
Yeah.
अच्छा, अब मैं देखता हूँ अगर उन्होंने आगे इसी तरह का पेज दिया हुआ तो मैं उसी से रेफर कर देता हूँ, अदरवाइज मैं फिर आपको इसी पे समझा देता हूँ. नहीं उन्होंने नहीं दिया. अच्छा, स्पीड टाइम ग्राफ के अंदर नाउ व्हेन इट्स अ स्पीड टाइम ग्राफ तो ये शेप किसको शो करेगी? कांस्टेंट स्पीड को, एंड एक्सेलरेशन वुड बी 0 बिकॉज स्पीड इज नॉट चेंजिंग. ये किसको शो करेगा स्पीड टाइम ग्राफ के अंदर? दिस वुड शो अ यूनिफॉर्म स्पीड which means speed is changing equally with equal interval of time, so the acceleration would be constant. बाकी जो ये दो ग्राफ्स हैं इनका वही मीनिंग है स्पीड टाइम में भी जो हम लोग यहाँ पे डिस्कस कर रहे हैं. ठीक है? अब एक और चीज है कि व्हेन वी आर टॉकिंग अबाउट द स्पीड टाइम ग्राफ्स हम एक और पॉइंट डिस्कस करते हैं, द स्लोप और ग्रेडियंट. ठीक है? Slope means quantity of y divided by quantity of x. ग्राफ्स तो आपने मैथ्स में रीड किए हैं ना, you know the x and y axis. So the quantity which is in y axis divided by the quantity which is in x axis, that is known as slope or gradient. It is also known as rise over run. Do we get the meaning of slope and gradient? Slope and gradient means whatever the quantity is in y axis divided by the quantity in x axis. So in speed time graph, what is given on the y axis? y एक्सिस में कौन सा क्वांटिटी होता है, स्पीड होता है कि टाइम होता है? इट्स स्पीड. एंड एक्स एक्सिस में क्या होता है? टाइम. अच्छा, डू यू नो कि एक्स एंड वाई एक्सिस के अंदर हम कौन सी क्वांटिटीज ड्रॉ करते हैं, डिपेंडेंट एंड इंडिपेंडेंट वन?
I don't.
Acha, whenever we draw the graphs now, the quantity which is independent, which means that changing that quantity would affect the other quantity. Such quantities are known as independent quantities. And the quantities which depends on other quantities are known as dependent quantities. So out of velocity and time mostly जो होता है वो independent quantity होता है, and the other quantity is considered as a dependent quantity. So y-axis पे हम हमेशा dependent quantities को draw करते हैं. And normally समझ में आ जाता है कि which one would be a dependent one and which one would be an independent. And x axis पे हम कौन सा draw करते हैं? हमेशा independent one. So when we are discussing about the slope of velocity time graph, so we have velocity in y-axis and time in x-axis, and velocity over time is given as acceleration. So gradient of velocity time graph gives acceleration, and gradient of distance time graph हमें क्या देगा? x-axis पे क्या होगा? Time, and y-axis पे क्या होगा? Distance. So this is giving us speed. So slope of distance time graph gives us speed, and slope of speed time graph gives us acceleration. Am I clear up till now?
Yeah.
अब जो last point है हमारे पास, that is area under the graph. Area under the speed time graph gives us distance traveled by the body. There are three shapes that we need to understand to find out the areas. That is this trapezium shape, okay, this rectangle shape, and this triangular shape. The area of the triangle is given as 1 by 2 base into height. This is height, sorry, base, and this is height. Okay. And the area of rectangle is given as base into height. This would be base, and this would be height. अब values हम obviously calculate कर लेंगे. This value minus this value would give us base, and this value minus this value would give us height. And there's this third shape, which is a trapezium shape. We normally like this one. ये अब हमारे पास ट्रायंगल बन रहा है, ट्रायंगल बन रहा है, रेक्टेंगल बन रहा है. अब मुझे बताओ इसकी बेस की वैल्यू क्या होगी? इस ट्रायंगल 1, रेक्टेंगल एंड 2, व्हाट विल द वैल्यू? फॉर्मूला हमने अभी डिस्कस किया. ट्रायंगल का फॉर्मूला क्या होता है?
1 by 2 into base into height.
बेस की वैल्यू क्या बन रही है हमारे पास इसकी, ट्रायंगल 1 की?
20.
20. एंड हाइट वैल्यू क्या बन रही है हमारे पास?
30.
आप रेक्टेंगल पे आ जाए. रेक्टेंगल पे उसका बेस कितना, उसकी बेस की वैल्यू क्या बन रही है? दिस इज 50. 50 minus 20. Yes, 20.
30.
और उसकी हाइट की वैल्यू क्या बन रही है? 30 again. Height is not changing, it would remain same. Plus आप इस रेक्टेंगल की वैल्यू, ट्रायंगल की वैल्यू क्या बन रही है? बेस की वैल्यू क्या बन रही है?
10.
एंड हाइट अगेन 30. सो जब हम इन सब वैल्यूज को ऐड अप करेंगे, दिस वुड गिव अस डिस्टेंस traveled by the body. अच्छा, अब मुझे ये बताओ, from O to A, how would you define the motion of the graph of the object from O to A if it's a speed time graph?
From 0 to A.
From position O to A,
It's accelerating.
is it accelerating or moving with constant speed or uniform speed?
It's accelerating. No, it's moving at constant speed.
Constant speed or uniform speed?
Uniform.
A to B जो है, it's moving with constant speed. And B to C, deceleration.
Okay.
Okay.
Mm-hmm.
अच्छा, if speed is uniform, तो acceleration क्या होगा?
Then the acceleration will be
Constant. When
okay.
speed is constant, तो acceleration क्या होगा? Zero. And जब speed is decreasing, तो acceleration क्या होगा? Deceleration.
Negative.
Deceleration. ठीक है? ये तो
Okay.
था velocity time graph. If I say कि ये speed time graph है, sorry, distance time graph है, तो O to A क्या show कर रहा होगा?
Distance time graph.
हाँ, if we say this graph is distance time graph, तो O to A किसको show कर रहा होगा? Uniform speed को. A to B किसको show कर रहा होगा?
Uniform speed.
नहीं,
Constant.
रेस्ट को. डिस्टेंस टाइम ग्राफ में ये शेप किसको शो करती थी? रेस्ट को शो करती थी. एंड B to C अगेन हमारा क्या आएगा? डिक्रीजिंग.
Wait, how does distance decrease?
डिस्टेंस डिक्रीजिंग स्पीड बोल रहा हूं मैं.
Yeah, but it's a distance time graph.
We are only discussing in terms of speed. I'm not saying the distance is decreasing. I'm only saying that the speed is decreasing. Distance तो हमारे पास actual path covered by the body जो होगा वही रहेगा. Now I'm giving you some time to digest everything that we studied today, and let me know if you have any questions regarding anything. If we like this and see O to A क्या हो रहा है? O to A to B and B to C. In speed time graph क्या हो रहा है? O to A.
Speed time. This increasing.
O to A क्या हो रहा है?
The speed is increasing.
मैंने what term would you use? Uniform or constant?
It's constant.
O to A constant आएगा, uniform आएगा? A to B क्या आएगा? यहाँ पे constant आएगा. एंड स्पीड टाइम में ये किसको शो कर रहा होता है? रेस्ट को शो कर रहा है. B to C अगेन क्या आएगा हमारे पास?
Constant.
यूनिफॉर्म. यूनिफॉर्म। अच्छा, यहाँ पे एक और पॉइंट डिस्कस करते हैं। मोर स्टीप एंड लेस स्टीप का एक कॉन्सेप्ट होता है। वी कैन सी हियर के O to A and A to B, which one is more steep? Steepness में O to A and A to B में से कौन सा, which one is more steep?
O to A.
ओके, आप इसको चेक करने का एक मेथड होता है कि टाइम हमारे पास कितना है यहाँ पे, फ्रॉम B to C it would be clearly 1.5 and C point would be 2.5. So 1.5 to 2.5 टाइम कितना बनेगा, 1 सेकेंड, ठीक है। एंड स्पीड जो है, डिस्टेंस कवर्ड 100 to 200 कितनी बन रही है, 100 किलोमीटर। ये तो आ गया हमारे पास A to B का डिस्टेंस एंड टाइम। अब O to A का डिस्टेंस कितना ट्रेवल है, अगेन 100 किलोमीटर। वी आर सीइंग दिस फ्रॉम हियर, दिस पॉइंट, एंड टाइम उसका कितना है, 1 सेकेंड। सो दोनों की values in terms of distance and time is same. So this means the both are exactly same. हाँ, अगर किसी ने same less time interval में same distance travel किया होगा, this would be considered more steep और the other one less steep. ठीक है, more steep
1 hour or 1 second?
1 hour.
Oh, it's
Sorry,
okay.
1 hour. More steep होता है more distance in less time. तो हम कैलकुलेट करेंगे like we have done this here. And less steep क्या होता है,
Less distance in more time.
yes, or even same distance in less time,
Oh,
same
okay.
distance in less time, in more time.
Okay.
Since यहाँ पे इक्वल थे और डिस्टेंस ट्रैवल्ड इक्वल था, तो दिस मींस के कोई लेस एंड मोर स्टीप नहीं था। बट अगर समवेयर, अच्छा ऑल्सो अगर हमें कैलकुलेशंस नहीं भी करने ना, आई एम शेडिंग द एरिया, वी कैन सी हियर के हाउ मेनी बॉक्सेस इट कवर्ड, 1 2 3 and 4 here and 1 and 2 boxes like this. Similarly इसने कितने बॉक्सेस ट्रेवल किए, 1 2 3 and सॉरी इसका डिस्टेंस कम था, श्रीनो, इट वुड बी, द डिस्टेंस ट्रेवल्ड इज लेस, हमने बाय मिस्टेक 100 लिख दिया है। दिस वुड बी, हाँ, दिस देन O to A would be more steep. Sorry, we could see ना, it's not reaching up to this point. अगर यहाँ पे कर रहा होता तो 100 बनना था हमारे पास, but it's somewhere below, तो I guess 50 distance 75 हो रहा होगा in the same period of time. So which is more steep? O to A is more steep and B to C is less steep because उसने same time में less distance travel. Okay? Are we clear about all the points now?
Yeah.
Go ahead and read it now, whatever the time is left.